hopefully that kind of enabled you to understand why linear algebra is so important. But now let's get to the how. How do we perform matrix elimination here? Before we get to the how, I need to discuss the what, the goals, okay? So my first goal is to eliminate J21 to 0, right?
0.
What's the next term I need to eliminate?
J31 and Z32.
In what order?
Uh,
J21, J31, J32.
Well, I'll give you some advice. The order we have to eliminate is from top to down and from left to right.
Yeah.
So, for example,
J21 to J31 to J32.
after J21, we need to eliminate
J30.
J31.
okay.
As simple as that. No harder. So,
But how to eliminate J31 if there's a 0 spot above it?
I'll show you. The magic will be revealed shortly.
The magic will be revealed shortly. Do you work your way up instead of down?
Professor, can you sit down?
Your
I-
professor is not sitting down.
Okay, folks. Now I've outlined my goals. My first goal is to solve for the variables. My next goal, achieve upper triangular form. My next goal, eliminate J21 to 0. And the rest is pretty evident. Now why don't we go ahead and do that? Our student Alex recommended that we multiply the first row by
I
-2.
recommended that.
Yes. And add it to the second row.
But I have a question.
Yes.
How
Please
to
tell me.
eliminate J31 when J21 is 0? Because if the spot directly above it is 0, then
Oh.
you can't solve it.
We will see how to do that. Okay, if I multiply the first row by -2, class, what do I get? Please tell me.
-4.
Okay, wait. -2 times 2 is?
-4.
Okay.
-8.
-8.
+4.
+4. And then there's one more term. -2 times 2 is -4. Now I want Alex to tell me what I should do now. I just multiplied my first row by -2. Now what should I do after multiplying it by -2? Do we have any idea?
Oh, we cancel. We eliminate.
We eliminate by adding.
Adding.
So
So
after
that would give you 2, 4, -2, 2.
wait. I want Alex to say it because what she meant is what matters.
Alright, -4,
High achievement, you mean, not
Yeah.
the lowest.
-4, -8.
Yeah. So
No, you have to do that first.
we have arrived at the first misconception, and that is this.
Okay, no.
When
Alright.
we multiply a row by a multiplier, we do not change the entries of the row. We keep it in our mind. Okay, so our first row will remain the same.
2, 4, 2. You sure?
But our second row is what we will change. So Alex, perhaps you would like to say what?
0.
0.
-8 plus 9 is 1.
1.
4 minus 3 is 1.
4 minus 3 is 1.
-4 and 2. Oh, -4 and 8 is 4.
And what is the last row of our matrix?
-2, -3, 7.
-2, -3, 7, and
10. So
And-
now we have to get rid of -2.
wow. Well, we have already accomplished one thing in our checklist, and what is that?
3.
We 3, right? Have we eliminated J21 to 0?
Yeah.
Yeah.
Eliminate J21 to 0.
See?
Wow, this guy's grammar is top notch.
Okay.
J21 is 0. What is our next goal? Do we know our next goal?
Eliminate J31.
J31.
Eliminate J31.
But how are
Okay.
you supposed to do it?
Well, let's see. Let's see how we can do that. One of our students, Isaac, he said, how can you eliminate something when the row above it has 0? Nice observation. That's why we don't use the row above it. We use the row 2 rows above it. The first
What?
row. That's right. Now, perhaps one of our students, Alex, I would like to recommend what multiplier do I have to multiply the first row by to
Nothing. 1. +1.
We have now arrived at the second misconception, and that is this. There was no misconception. Okay? Alex was actually right. The idea is that many students believe the multiplier cannot be 1 or 0, when in fact it can. All you need to do is eliminate negative 2. So, if I multiply the first row by 1, what does my new row become?
Okay, wait, 2, 4, negative 2?
So, if I multiply my first row by 1,
This marker is really hot.
what will my new row become?
0?
No.
No,
1,
2,
2.
Oh.
2,
No, I was not.
4, negative 2, 2.
It's a new row.
Yeah, new row. New
Okay.
row.
So I'm gonna write
New
2, 4,
row,
negative
not
2,
new
2.
matrix.
Okay, so let me go to the next stage.
I'm fast.
2, 4,
Yeah.
negative 2, 2. 0, 1, 1, 4. 0, 1,
Okay,
5.
so what will my first row be? Alex.
2, 4, negative 2, 2.
No. I want Alex too.
Negative, so 2, 4, negative 2, 2.
2, 4,
Negative
negative
2, 2. 0, 1, 1, 4.
0, 1, 1, 4.
0,
0,
1,
1,
5,
5,
12.
12. So let's take a look and see how Alex did that. Okay?
Alex is genius.
And as a matter of fact, he is. Because
Alex is gonna apply to replace you.
I would not recommend that. It is a dangerous
He
maneuver.
doesn't know half the things you know, Professor.
Okay, so what has Alex done? He has simply added the new row with the third row. 2 plus minus 2, 0. 4 minus 3, 1. Minus 2 plus 7, 5. 2 plus 10, 12. Now we are almost done. Folks, have we achieved anything on our checklist?
Yeah, almost. The 4. We accomplished 4. Now
Yeah.
we gotta do the 5.
We have eliminated J31 to 0. How do I know that?
This guy
Look.
remember.
J31 and J21 are both 0.
Yeah.
What is the only thing?
Now let's multiply the second row by negative 1.
Yes. That is the next step.
Can you do it quickly? I have to go to the protest.
Oh, yes. Negative
God,
1.
Professor, this is even going on at like 2 a.m.
Okay. So now, perhaps our student Alex.
Oh my god, I have to go to the
This
protest.
is important to highlight the low achieving students in your classroom. Please do that.
No, I really need to do this because if Alex will go to the protest,
Oh,
there's
no,
no
no.
one else.
Okay, you can finish the last step. But Alex, can you please tell me what my last matrix will be?
No, he really needs. Oh God,
And,
he's outside.
I have to go to the protest.
Oh
Oh, it's curfew time. But Alex, would you tell us what the next step of the matrix is?
no, he left the
After I
room.
multiply
Oh, no.
this row by negative 1 and add
Okay, so 2, 4, negative 2, 2.
Okay, so let me write it down. 2, 4. 2, 4.
Can you do the existed now?
Yeah, we are almost at 2, 4,
Two.
negative 2. 2,
0, 1, 1, 4.
0, 1, 1, 4.
0,
0,
0,
0,
4.
4,
4,
11.
11.
No. Negative 4,
8.
8.
Which one is it? I don't.
The 11 would be 8.
Oh.
I'm so happy.
Unfortunately, 1 second, please. So I cannot trust this. So let me just double check. So multiplying negative 1 by this row gives me 0 plus 0, 0. Minus 1 plus 1, 0. Minus 1 plus 5,
See, you can
4.
trust this
Minus
guy.
4 plus 12, 8. Now,
So 4 is equal to 8.
oh, but have we achieved anything on our checklist?
Yeah, everything.
Yes, 832.
And now we arrive at the exit slit.
Oh wait, no. You have to cross off 2.
Oh, okay.
We've achieved upper triangular form.
Okay, so our exit slit is gonna be to solve for x, y, and z. But before I do that, I just want to show the audience that I'm not lying. See, this is the upper triangular form I was talking so much about. And you should by now understand why upper triangular form is so important. Now I will enable our student Isaac to back solve and solve for x, y, and z. So good luck. Thank you.
Wait, what? Thinking.
And this is the exit slit.
Think he's outside now. He's going into it.
So our exit slit, maybe I should repeat it, is to solve for x, y, and z. aka our first and last.
4z is equal to 8.
Okay. Oh, perhaps our student Alex would also like
No,
to.
I would like to do it because I think Alex is about to join the revolution. So z equal 2. So y plus 2. No, y plus 2 equals to 4. Y equals 2. And then
While our student is solving the matrix, I would like to speak to the amazing utility of matrices in the real world. Have you all heard of facial recognition? If you haven't, I recommend you take a look at our new newspaper, The Thinker. We describe the utility of linear algebra in all its applications, including facial recognition, traffic lights, and machine learning. So, as a matter of fact, machine learning and artificial intelligence is based 100% on linear algebra. And you might think, why is that? Well, you see, images. For example, if you want to... Oh, are we done?
Oh yeah.
Oh.
So x is -1. Sorry to interrupt.
Okay, so our student Isaac has solved for x, y, and z, and he has gotten x is -1, y is 2, z is 2. All right, folks. Now, to check if that's correct, because as a matter of fact, it is
You can't
correct.
trust anyone.
So,
you have
thank you for watching, and we'll see you next time.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.